Hey guys, welcome to my channel. So today's our Leetcode Daily challenge problem is count the number of consistent strings. Okay, so what does the question state? So you are basically given a string allowed, okay, consisting of distinct characters, and you are also given an array of strings, words. Okay, now a string is consistent if all the characters in the string appears in the string allowed. Okay, so basically you are given this allowed string and a vector of strings, words, and in this like various strings are given. Now you have to find the consistent strings among these strings. So what is the consistent string? When all the characters present in this string is present in allowed string. So in this AD, D is not present, so it is not consistent. BD, D is not present in AB, so this it is also not consistent. And AAB, A and B both are present, so it is consistent. Here, this is also consistent. Here, D is not present, so it is not. So basically, we have written two. Okay, so these two strings. Similarly, in this, ABC is the allowed string. A, B, C, A, B, A, C, B, C, and A, B, C all are present in this particular string. So all are consistent. So we will return the count of all these strings. That is 7. Okay. Hope you have understood the problem. So there are multiple approaches for solving this problem. So the first approach would be we will be using set. Okay, so what I will do is here basically in n I have taken the size of this word vector. Okay, now I will iterate. Firstly, I will iterate through this allowed or allowed string. Okay, and I will insert all the characters into the set. Here I have taken this set of string type. Okay, and then I have taken this count variable. This will count the consistent strings. Okay. Now what I will do is in this loop basically I will for the first loop I will traverse this vector words. Okay. And this in the inner loop I will be traversing the characters of each string. Okay. So currently we are at index 0, that is this particular string AD. Okay. Now what I will do is I will check s dot find words of I of j, that is a character. That is a character is present in the set, and set contains a and b. Okay, if it is present, then what we will do? We will do nothing. Okay, here I have taken this flag variable because this flag will remain one if all these characters are present in this string, and if not, if any of the character is not present in this string, then I will mark this flag with 0. Okay, and at the end of this particular loop I will check whether the flag is 1 or not. If it is 1, that means all the characters of this string is present in the allowed string, so I will increment my count variable, that is this string is consistent. Okay, so flag will remain 1 for this A. Then I will come to D. Okay, for D, this when I will find this D character in the set, uh, it is not present. Okay, so if it is not present, what I will do, I will convert this flag from 1 into 0, and I will break it because one character is not matching, that means it is not consistent. Okay, so I will break, so I will move out of this particular loop, and here if a flag that is 0, so nothing will happen, count will remain 0 only. Okay, similarly for B and D also count will remain 0. For this, A is also present. B, this A all like A is already present in the string. B is also present. So basically, this string is consistent. So count will value will be increased. Okay. At the end, I will return the count. So for this and this, the count value will be increased. So count, I will return the count value 2. Now, looking at the time complexity of this particular solution. So firstly, I will be traversing this vector, right? So the O of n for where n is the size of this vector, and here this is particular the size of the string. Okay, so the average size of the string. So suppose this is m, so complexity will be n into m, right? And at the same time, I am also using this set. So find function is being used. So set will take approximately log of n. Okay, and its average time complexity is log of n. So the time complexity is n into m into log of n, log of the size of the string, log of the set value. Okay, the set size basically. And if I take unordered set, then also the find operation average time complexity with O of 1, but the worst time complexity is O of n only. Okay, so can we further optimize this particular approach? Okay, so basically we can. Okay, so for this, let me first comment it out. Okay, so what we will be using uh, for optimizing this particular solution is I will be using a bit mask. Okay, so for those who don't know bit mask, so basically it works on bits. Okay, so and the thing that you will like, how would you came to know that you should use bit mask or not? See the here, as you can see, allowed string is there. Okay, and the length of the allowed string is 26. And if I take integer if we take integer value, its capacity is of 32 bits. Okay, so it is under the 32 bits, so it is better to take bit mask. Okay, so how we are going to use the bit mask? What I will do is, firstly, I will take one integer value. Okay, so integer value basically 32 bits size is there. Okay, and what I will do is I will traverse through the allowed string. Similarly, I was doing here also. Okay, and instead of inserting into the set, I will insert it into the bitmask. So see, bitmask is 0 here. That means this simply means that our bitmask is 000, like uh, up to 32 bits. It is this. Okay, now what I will do is the string length is 32 is 26. Okay, and the number of characters are also 26. Okay, as they are distinct, so obviously 26 are there. So whenever I encounter any character, I will like, if A is there, then I will mark this zeroth index value with 1. If B is there, then I will mark this first index value with 1. Okay, in this way. And at the end, when I, like in this particular thing, what I was doing, I was storing in the characters, and I was searching in the set. Okay, so instead of that, what I will do, I will perform AND operation of bitmask. Okay, and that particular characters. So if the character is B, that means this particular 1 would be here. So this particular bit 1 here, and this whole of the string of the bit mask. Okay, in this way we will search. So the time complexity will be O of 1. Okay, so so let me guide you through the code. So here I have taken this allowed string. I am iterating through it. Okay, and I will basically this is for setting the bits in the bit mask. Okay, so basically what this is basically the position. Okay, that on which position you have to set the bit, and what do you will set? This one value will be set. So initially it is 0, so all the 32 bits are 0. Now suppose the string is A and B. Okay, so I am traversing through this particular string, so I am at currently A, so IT represents A. Okay, so IT represents A minus A. Like the ASCII value is 97 minus 97, that is 0. So zeroth position. Okay. So so it is basically saying that on zeroth position of this bit mask, okay, mark it as 1. So zeroth position will be marked as 1. Okay. So it simply represents the eighth index, that is A is present in this particular allowed string. Okay. Then I will come here B. Okay. So B is so character of B minus B, that is 98 minus 97 is 1. Okay. So it is saying that on the first position set the bit to 1. Okay. So this is our first position. So I will set it to 1. Okay, in this way then the loop ends. Okay, so this is basically the syntax of setting the bit in the bit mask. Okay, so this is our string. Okay, now it is a 32-bit string. Okay, now I will come here. Okay, so I will here again I have taken this count variable. This will simply count the number of consistent strings. Okay, again I am doing the same thing that I have done before. I am traversing through this vector of strings. Okay, I have taken this flag value as I have taken before. The only difference is instead of s dot find, like finding the value in the set, I will be finding the value in the bit mask. Okay, so now I am traversing through this particular vector. Okay, and now here I am at this particular index. Okay, so I am traversing through the each character of the string. So I am currently at A. Okay, so what will happen is bit mask, and I will perform AND operation on this bit mask. So bit mask is this, okay, and AND operation on what? Character of a minus a for this, okay. A minus a would be 0 only. So basically, here, like here, this is 0, okay. So basically, a is present, okay. So a is there. So now we will perform AND operation on these two values, okay. Uh, on these two values, and what will be the AND operation? See, all the other values are zeros only, okay, like all the dots are zeros, and here also all the things are zero. So if I perform the bit operation on this AND operation on this particular thing, so the answer would be 1 only, okay. That is AND of 1 and 1 is 1. Here it's 0, so AND of 1 and 0 would be 0, okay, in this way. So previously all the values are 0, so it is 1, okay. That means basically it will check is equal to 1 or not. So if it is 1 here, so this condition do not satisfy. That means up till now the string is consistent, okay. So I will not do anything. As soon as I encounter some value that is not present in this particular bit mask, like when I take end of the this particular character and this bit mask, if it becomes 0, that means this particular character is not present in the string, and I will break flag is equal to 0, okay. And again, that like we were doing in the set for this particular code, we will do the same thing, okay. So now we are at the dth index, okay, d. So here I will check that bit mask. So bit mask is this only, okay. And like d minus a, so d minus a would be the d's ASCII value would be 100, okay. So 100 minus 97 would be 3, so third bit, okay. So basically our new this would be 3, okay, and this way. So now we will take the AND operation of this particular thing, and it will be 0 only, okay. So here basically everything would be 0. So for the all the 32 bits, it will be 0. So this is our new answer. Okay. So is it equal to 0? Yes, it is equal to 0. Okay. That means this D is not present in this bit mask. Okay. So basically I will make the flag to 0 and I will break. Okay. So nothing will happen. Then I will come here again. D is not present. The same scenario. In this B is present, but D is not present. So again I will move out. In this a means 1, okay. So here it is basically 1, and here it is 0, and here it's 1. So 1 and 1 AND operation would be 1. That means it is not equal to 0. That means string is consistent. For this is a, this a, and this a, all three is this particular string will be consistent. Then B will come. So for B, the second bit would be 1, okay. This and our sorry this would be our for B, okay. Now if I take AND operation, that means this. So basically the AND operation would be 1 only, okay, of this 1 and 1, okay. So that means it is not 0. So flag would remain 1 only, okay. And at the end we will come out of this loop, and flag the count value will be increased by 1. Here also count value will be increased by 1. Here it's not, okay. So in this way we will use the bit mask. Now if I run it, okay, there is some error. Okay, I forgot to comment this particular parenthesis. Yes, it is accepted, and if I submit it, yes, it is accepted. Okay, so guys, basically we have reduced the complexity. Okay, now the complexity would be O of n for this traversing this particular vector, and for the character and the average of all the characters, average of all the string lengths. Okay, and the bitmask will take the complexity of O of 1 only. Okay. So hope you have understood this problem, guys. If you like this video, give me a thumbs up and subscribe to the channel. See you in the next video. Till then, goodbye.